about classifying triangles. You remember acute, right?
Yes.
Scalene, isosceles, and equilateral, right? So when we classify triangles, we can give them two different names, one for their angles and one for their sides. When we're classifying quadrilaterals, we're going to kind of combine angles and sides, and that's how we figure out what its name is going to be. So a quadrilateral is any four-sided figure. Quad means four, right?
Yes.
And tri means
Three.
okay? So a three-sided figure is a triangle, a four-sided figure is a quadrilateral. Okay? Closed figure, that means the lines all meet up. It's closed. And they're going to have four sides, four angles, and these diagrams that are on the first page of your notes give us the most common ways that quadrilaterals are classified. So when you look next to the word quadrilateral there, right here, it has this four-sided figure, but it kind of looks lopsided, and none of the angles are the same, and nothing's really parallel. It's just a four-sided random figure, right? Okay, so one of the things that branch off of this quadrilateral over here is, what's this word? Trapezoid. So the definition for a trapezoid is a quadrilateral with exactly one pair of parallel sides. So if you notice this picture, we have two little red or pinkish triangles that are pointing the same direction on the top line and the bottom line. These are marks that show us parallel lines. Now, if you'll remember triangles, we had these little hash lines like this center figure has, the parallelogram, has these little hash lines to show us which lines measure the same length. We use the little triangles to determine parallel lines. So these two lines in the trapezoid here are parallel to each other. They're exactly the same distance apart all the way along the length of the line. Okay, so this means parallel. These two little triangles right here mean parallel. And a trapezoid has one pair of parallel lines. Okay? And that's pretty much the only defining thing about it. It doesn't have all its angles the same. It doesn't have any of that other stuff, just one pair of parallel lines. Trapezoid. Now, another branch off of quadrilaterals goes to parallelogram. And parallelogram is a quadrilateral that has the opposite sides are parallel, so you notice this line on the left, this line on the right, both have one arrow. That means these two lines are parallel. And then the top and the bottom have two arrows, which means these two lines are parallel. So these two and these two have two pairs of parallel lines. Okay? And then we also see that the other part of the definition of parallelogram is that the opposite sides are also congruent. So if you notice, the left and right side both have one little hash mark. They're the same length. Then the top and the bottom have double hash marks. They're the same length. Okay, so we have two pairs of parallel and congruent sides for the parallelogram. Didn't say anything about angles here. So their angles are not going to be congruent. Okay, over here on the rectangle, which is a kind of parallelogram, now we've got parallel and we've got congruent, but we also have 90-degree angles, four right angles. Okay, so a parallelogram that has four right angles is going to be a rectangle. And a special kind of rectangle is a square. Okay? A square has four right angles, but it has four congruent sides. All the sides are the same. The difference between a rectangle and a square are the congruent sides. A square has four of them. A rectangle has two pairs. Top and bottom, left and right. Okay? And then if you take a square and you kind of squish it down a little bit so that the angles aren't 90 degrees anymore, you have a rhombus. All four sides are still the same length, but the angles are not 90 degrees anymore. So that's a rhombus. The rectangle, the square, and the rhombus are all kinds of parallelograms. And parallelograms and trapezoids are kinds of quadrilaterals. So it's kind of a little tree here, tree diagram. Okay? A square is a parallelogram, a rhombus is a parallelogram, a rectangle is a parallelogram. questions? A trapezoid is not a parallelogram. It is a quadrilateral. All right. So let's look at this in a different way, kind of a Venn diagram here, where we have in the middle our Venn diagram with rectangles, squares, and the rhombus. This says rhombi, meaning more than one. Both of these are plural. You'll notice squares is in the middle. Squares are rectangles, and squares are also rhombi. Okay, rhombuses. Okay? So squares kind of fall under everything. Squares are quadrilaterals, squares are parallelograms, squares are rectangles, squares are different kinds of rhombi. Okay? All right. So let's take a look at this part down here that has a big old couple of stars by it. Remember not to make any assumptions when you're classifying quadrilaterals. In other words, if it's not marked with parallel lines or 90-degree angles, we can't assume that it's parallel lines. When we're looking at some of these, in number one, these are not marked parallel, but because all four angles are 90 degrees, they have to be parallel. Just because of the fact that they're 90-degree angles. Okay? That means those lines are parallel. When we're looking at number 6, it does not have 90-degree marks. It does not have parallel lines. We can't assume that these are parallel. They may not be. Okay? The only time you know for sure that you have parallel lines is when you have 4 right angles in the corners, or you have the parallel line marks on the figure. Okay, so otherwise don't assume that they're parallel. And when you're looking at a figure, don't assume, well, these two look like they're the same length, so I'm going to say they are. Or these two look like they're the same length, so I'm going to say they are. If they don't have the little marks on them, don't assume that they're the same length. Okay? Questions about that? Okay, so for number 1, what kind of quadrilateral will this be? Look at your notes. A rectangle. We have 4 90-degree angles, 2 opposite pairs of congruent sides. So that matches our definition for rectangle that was earlier in the notes. For number 2, what is this? It's a quadrilateral. Are there any parallel lines? There are no parallel lines. So therefore, it's not a trapezoid, because trapezoids have 1 set of parallel lines. Parallelograms have 2 sets of parallel lines. So it's just a plain old quadrilateral. How about number 3? If it's a rectangle, it has to have what?
Parallelogram.
That's right, a parallelogram. If it were a rectangle, we'd have to have the little 90-degree marks in the corners to show us that. But since we have opposite pairs of parallel lines and opposite pairs of equal length lines, it's a parallelogram. Okay? Number 4. What do we got here? Rhombus. Why do you say that, kid? All the 4 lines are congruent, and they don't have what? It doesn't have what? Why isn't it a square?
They're not right.
Very good. Devin, they are not 90-degree angles in the corners, so it has to be a rhombus. How about number 5? Quadrilateral. Why is it not a parallelogram?
Because it doesn't have any parallel sides.
No parallel sides, so could it be a trapezoid?
No.
No, trapezoids have to have at least 1 pair too. It's a quadrilateral. I'm just going to write quad here. How about this last one?
No. Quadrilateral.
Quadrilateral. Why can't we say for sure that it's a parallelogram?
Because it doesn't have like a little
Very good. Very good, guys.
Triangles.
It doesn't have our little triangles that indicate that it's a parallel line. It doesn't have those. We can't assume it, so we're going to say it's a quadrilateral. Okay? Questions so far? Okay. So now I'm going to give you a little bit of time, and I want you to work through 7, 8, and 9. And what you're supposed to do is read this and figure out if you could draw this figure. Can you draw a quadrilateral that is both a rhombus and a rectangle? If you can do that, I want you to go ahead and try it. If you don't think it can be drawn, then you need to explain why you can't draw it. Okay, so I'm going to give you about 5 minutes here to work through it by yourself, and then get with a partner and see what they think. I want you to work it yourself first, though. And in a couple minutes, I'll tell you to get with a partner and see what they think, and we'll see where we are. Okay, so for number 7, a quadrilateral that is a rhombus and a rectangle. Can we do that?
No.
Why can't we do that?
Because the rectangle is over.
Wrong. I just said that.
I know
A
you.
rhombus doesn't have
90 degrees.
right
Rectangles.
90-degree angles. That's why we can't draw it. A rhombus does not have 90-degree angles. Okay? Yes, Eva. Okay? For number 8, that's not your test. For number 8, a trapezoid with 3 right angles. Can we do that?
No.
Okay, so if we tried to draw 3 right angles, here's one.
I did like a square and then having them out, but it didn't.
You're either going to have a square or a rectangle with 90-degree angles, right? It's either going to be a square or a rectangle. Okay. For a trapezoid with 2 congruent sides.
No.
Yes. Yeah, you could draw a
Oh, wait.
square, and then instead of having, you could draw one going out, and then
You said 2.
So how many people think yes, you can draw a trapezoid with 2 congruent sides?
Me.
But your parallel lines be congruent?
No.
Yeah.
If your parallel lines were congruent, what does that make your other 2 lines?
It'd be a square. It'd be
It
a
would be a rectangle.
It has to go out.
Okay? What if we drew it? Quiet, please. What if we drew a pair of parallel lines, and then what, Julia?
But connect. Wait. I drew it like
I don't.
that.
Got that one? Yeah, you could do it like that too. Okay. So there's a couple of different ways that we can do it. We can do it if these 2 lines, I'm sorry, they're kind of crooked, at the end are congruent, like
A
this.
standard trap.
And then Julia said, what if we have parallel lines and these are parallel, going out like that, and these 2 are congruent. Okay, so now we have our trapezoid because we have our parallel lines, but we also have 2 congruent sides on our trapezoid. Okay? A couple of different ways you could have done it. Okay. And your